Let's take a look at osmosis in action. A good example of this can be seen inside a guard cell, which surround stomata, mainly on the underside of the leaf. So the function of stomata is to allow the exchange of gases, but sometimes too much water vapour will leave, so the stomata needs to close. So the stomata close using osmosis. Now, I've used yellow circles as an example of solute in the past, and this time the solute is going to be potassium ions. So what will happen is potassium ions will be moved into the stomata. Now, if the potassium ions are moving into the stomata, it means you've increased the concentration of solute. So the water will then follow by osmosis, because osmosis is the movement of water from an area of low solute concentration to an area of high solute concentration, or from an area of high water potential to an area of low water potential. So the water will enter the guard cell and the guard cell will swell up. Now this area here is slightly thicker than the rest of the cell. So as the water moves in, it swells unevenly and the guard cell will open up the stomata. Now, when the plant is under quite a lot of water stress, you need to close the guard cell so not too much water vapour is lost through transpiration. And the way the cell will do this is to move the potassium ions out of the cell. Now, when you move the potassium ions out of the guard cell, the water will move by osmosis, as previously described in the guard cell on this side. So what you've got is you've got the water will move by osmosis from an area of low solute concentration, which is inside the guard cell, to an area of high solute concentration, which is outside the guard cell. The water will then follow, and when the water follows, the plant cell will lose turgidity, so it will become flaccid. So this side is turgid. When the guard cell is open, the water is lost, the cell will become flaccid, and if both guard cells on both sides become flaccid, then the stomata here will close.